So now that we've learned about how to name ionic compounds and covalent compounds, and also go from a formula to a name or a name to a formula, we want to think about how we order the elements in that formula if it's not apparent by the name or by a formula already given. So this would be in the example of if we were given the structure of the compound and asked to write the chemical formula for it. What order do those elements go in? Okay, now this usually occurs more frequently when there's multiple atoms in a compound. So we'll start off with our example of that. So we have two rules that we have to follow when ordering elements in a chemical formula. The first one is if the compound contains carbon, what we're going to do is write carbon first, then we're going to put hydrogen second if it's present, and then after that, every element will show up in alphabetical order. So I have an example of that here. In this compound, all of our elements are labeled so that we know their color, and we're going to follow our rules. So we're going to have carbon first, hydrogen second, and then we have nitrogen and oxygen. So nitrogen would come third, and oxygen would come fourth. Now we just have to count up the number or the amount of each of those atoms in that compound in order to write their subscripts. So for carbon, I have 1, 2, so I would do C2. For hydrogen, I have 1, 2, 3, 4, 5, so that would be H5. For nitrogen, I only have 1. Remember, if we have a subscript of 1, we don't have to write it, so we could just leave that as is. And then for oxygen, I have 1, 2. So our compound formula would be C2H5NO2. Let's look at our next rule. So if the compound does not contain carbon, then we are going to write the elements in the order that they appear left to right on the periodic table. If they're in the same group, the heavier atom will go first. So we have some examples here. We have zinc oxide, ZnO, we have SO2, NaCl, and P2O4. Now a lot of this ordering for this rule here, for our second rule, comes out in our rules for writing ionic compound formulas, where we put the cation first and the anion second. And that's because the cations are present on one side of the periodic table and the anions are present usually on the other side. So if we draw our periodic table here, okay, we typically have our cations on this side and our anions over here. We get a few cations this way here. So we write the elements in the order they appear from left to right, so from one side to the other. So we go from cation to anion. And if they're in the same period, they would then go from the heavier atom goes first. Now we have talked about a few exceptions to this without actually calling them exceptions, and that was when we were talking about covalent compounds with specific names. So something like NH3, H2S, H2O, okay, those all have specific names to them that don't follow our typical naming convention for covalent compounds, and this also happens sometimes with ionic compounds as well. So the ones that have specific names don't follow these rules. We could also look at it as if we have a compound and there's an atom that's at the center and then there's atoms coming off of it. Okay, we write the compound in the center first and then we write the surrounding second. So if we're given the structure and we see an element in the center, that's the one we write first, and then everything after that. And again, that does typically follow this second rule of writing from left to right and then from bottom to top. So I have a few examples of that just from compounds that we've talked about earlier, just to prove that this does work. So let's practice with these carbon-containing compounds first. So this would be, everything here has carbon, so we write carbon first, then hydrogen, and then everything else in alphabetical order. So our red is oxygen and our blue is nitrogen, so we'll just keep that in mind. Okay, so this first one here, I have carbon and black. So carbon, there's one of them, so I'm not going to write a subscript. Then I write hydrogen, 1, 2, 3, 4, 5. These white ones are hydrogen. So I have 5 hydrogens. And then my last one is nitrogen. There's no oxygen or anything else, so I don't need to worry about alphabetical order after that. Let's look at this compound over here next. I have a carbon and some oxygens and some hydrogens. So we're going to write carbon first. There's only one, so I don't need a subscript there. Then I write hydrogen, so there's 1, 2 here. And then I write my oxygen, 1, 2, 3. Okay, so I've done 2 examples for you. I want you to try some on your own. So write the formulas for these 2 other compounds, where blue is nitrogen, red is oxygen, black is carbon, and white is hydrogen. So try writing those formulas using our rules. For this large one, we have C, H, N, and O. So we know we're going to put that in C, H, N, and O order. So for carbon, we have 2. Hydrogen, there are 3. Nitrogen, there's 1. And oxygen, there's 1, 2, 3, 4, 5. There's 5. So C2, H3, NO5. For our next one, we have C2, H, 1, 2, 3, 4, 5, 6, 6, and 1 oxygen. So those are our formulas for those compounds. Now I just want to bring back some of the compounds we talked about a little bit earlier in our notes when we were talking about covalent compounds, where we looked at the structure and wrote the names. Now we have a little bit more explanation as to why we write those names as is. So again, these are ones where we would write the compound that's in the center first, and then the surrounding atoms after that. And this does typically tend to follow the rule of we write left to right on the periodic table and then bottom to top in that order. So we have something here like phosphorus is light blue, so we have P1, and then brown is bromine, Br5. So phosphorus is in group 5, and bromine is in group 7. So we go from left to right on the periodic table. Then we have, let's see, yellow is sulfur, and then we have teal is fluorine, so F4. Okay, so again, sulfur is in group 6, and fluorine is in group 7. Again, these are just structures that we've looked at earlier that we wrote the formulas for. We just didn't have a direct explanation as to the order at which we were writing them in. But now we have that explanation, so we're just proving that concept. In our final one here, we have nitrogen in dark blue, and then our teal is fluorine again, and there's 3 of them. So nitrogen is in group 5, and fluorine is in group 7. So again, left to right.